Hi, my name is Thomas Kim. In this session of video, I am going to implement C++ code to solve linear congruence equation. To understand this algorithm, you have to watch three videos. One is my previous video, and two others are YouTube video from different YouTubers. After watching the videos, please watch this video. This session of video continues from my previous video, how to implement extended Euclidean algorithm in C++. In this video, I implemented extended Euclidean algorithm, and next I implemented Euclidean algorithm theory and implementation. In this video, I explain how to implement the Euclidean algorithm. And Cathy Frey's video about solving linear congruence with one unique solution, and also solving linear congruence with multiple solutions, finding modular inverse. Cathy Frey's 3 videos helped me understand, classify linear congruence, and also Math with J's video, solve linear congruence using Euclidean algorithm. This video gave me insight how to use extended Euclidean algorithm to solve linear congruence. Also, John Bohr's extended Euclidean algorithm. This video gave me understand how to implement extended Euclidean algorithm. I will put these links in the comment section. These are actually these videos, and I highly recommend you watch these videos to follow with me and implement linear congruence in C++ code. Please watch them and follow with me. This equation can be classified 3 different ways. To solve this equation, we first let G greatest common divisor of A and B. We first compute greatest common divisor of A and B. Then first, if G equals 1, then we have 1 and only one solution. Only one solution we have. Second, if G is not equal to 1 and K is divisible by G, means K modulo G is 0, divisible by G, then we have G number of solutions. If G is not 1 and K modulo G is not 0, means K is not divisible by G, then we have no solution. So I will summarize this into C++ code. We'll have something like this. Vector with return value will be vector int. I will say linear congruence, linear congruence, this is function name, we'll get argument as parameter a, k, b, of course int, a, k, b, like this. This is return value. We first calculate g. I will declare return value vector int. I will say solution solve. Then we compute g int gcd ab. At this point, if g equals 1, then we solve one and only one solution. We will handle this code here. Else if g is not 1 and k modulo g equals 0, then we say multiple solution. We will say multiple solution. Multiple solution. Here else have no solution, so it ends. Then we return solve. So I will detail about this algorithm. Two algorithm. First, it has one solution, one and only one solution. This is G number of solution. G number of solutions. Otherwise, no solution. So we return. This sol is the vector that it will contain container for our solution. In this case, I will talk about this case, OOG, one and only one solution case. We will code like this. We have to first compute inverse, multiplicative inverse. We will compute things like this. A inverse times A 1 mod B. We find this solution, this multiplicative inverse first. To find multiplicative inverse, we use is computed using extended Euclidean algorithm. About extended Euclidean algorithm, please watch my previous video. I will put the link below. If we get this number, then we multiply here. Each side we multiply. A inverse times AX. A inverse K mod B. we multiply multiplicative inverse to each side of the equation. Then it becomes identity 1, then leaving x. This side is the solution we want to find. A minus k. This is the solution. Finally, here it can be bigger number than b, modulo b, so we apply modulo operator once again, like this. This is the solution, one and only one solution. OOOS, one and only one solution case. I will label it like this. I will erase it and I will summarize like this. One and only one solution case. Solution will be A inverse times K modulo B. This will be the solution. Now we are turning our eye to multiple solution. Now we are talking multiple solution. Multiple solution case. So please note that we are solving this equation. Ax k mod b. Here g is not 1 and k is divisible by g. Here GCD A, B is not 1 and K is divisible. K modulo G is 0. This case, in this case, I'm making a quote here. First, we let A1 like this, A1, A over G, B1, I will say K1, K over G, B1, B over G. We let like this. And we have this equation changes. If we divide each side like G, for example, we divide Ax K mod B, we divide G, because K is divisible. It means K is divisible. We let A prime X prime K prime mod B prime. Then we take G2. I say G, okay, G2, I will say G1. We don't need to, okay, I will explain. G1 equals GCD A, this is not A prime, A1, K1, B1, like this. A1, B1 gives G1. This should be 1. Why it should be become 1? I will explain here on this side. Please note that we defined A1 like this. Then A becomes GA1, K becomes K1, GK1, GK1. B becomes GB1 like this. KAB. If we take them, G equal GCD, GA1, GB1. So it should be G. G is not 1. So this means A1 and B1 means they are relatively prime. A1 and B1 are relatively prime or coprime. So this should be 1. If it becomes 1, we can apply this case again. So we are solving this equation now. Using again Euclidean algorithm, we compute G1 inverse. We compute using extended Euclidean algorithm. Extended Euclidean algorithm. So if we compute A1 inverse, multiplicative inverse, then we can apply here. We can apply here again. Then it becomes A1 inverse times A1x. I will say A naught. Then we also have to apply this side. K1 mod B1 like this. So it becomes 1 again. So x0 becomes A1 inverse K1. This is the solution, but we want to make it smaller using modulo B1. This is the first solution of this case, multiple solution. This is the first. We said we have G number of solutions. So this is the first. We are making loop like this. x1, x0 plus b1. Then x2 will be x1 plus b1. b1 is this number. So we can say xg will be xg minus 1 plus b1 like this. In C++, we can let like this, x plus first in this case, here, we have to put it to solution vector here. So we say sol in place back x0. We put it 1. Okay. Then we do loop for int I equals. This is base case. We already done. So it starts with 1. I should be less than or less than g. This G is not this one, not this one, but this one, this GCD, x plus I. Then here we compute like this, x naught equals x naught plus b1, like this. Then we put solve in place, back x0. Then we compute all solutions, G solutions, and we put here, in the container, solution container, this loop, this part of code is multiple solution. So this part is multiple solution. Then here we return solve. I will summarize it. Here, A prime, A1 equals A over G, B, K1 equals K over G, B1 equals B over G. Using extended Euclidean algorithm, we evaluate A1 inverse, we evaluate, then x0 becomes here, x0 becomes A inverse K1, this one, modulo B1. This is x0 case. Then we do loop for int I, because it starts from 1 because we have to push it, insert in the solve in place, back x0. We insert, then for int I equals 1, I less than g. This is not g1, this is g, this one, plus I. We look next here, x0, we should say x0 plus b1, but this is actually equal like this, plus equal b1. This is actually equal the same. Then solve in place, back here, x0. Then we look, this is multiple solution case. So this goes to this block. So we return. So here we actually, in this case we missed one. Here, solve, in place back. We have to insert the element, this element, x, like this. Then we have general linear congruence solution. Now I move to my desktop and I will implement in C++ code. To follow with me, please download sample source code from this website. This session will build on from my previous session. Please download this sample code from this website. After downloading, unzip it. And we are copying it to our working folder. I will paste it here. This sample code has some problems. I will open it. I found a few bug here. This is from our previous session. This is Euclidean algorithm. Extended Euclidean algorithm. And here I found bug. This should be fixed like this. int a1 a b1 b. We should fix like this, and it should be b1 a1 a1 b1. Then it should be a1 b1. Then the rest is the same. I should fix like this. Extended Euclidean algorithm using recursion. ax plus by gcd a b. It solves equation like this. Also, here the same thing using loop. I also found it can fail sometimes. This loop method sometimes can fail. So if here I make a changes here, if count greater than or equal max count, it should be fixed like this. Then return 0. This is to prevent crash case. When it exceeds maximum count, then it will return 0. Here. Then I will make it like underscore I will change it. int gcd loop a b x y. If g is 0, g is not 0, then return g. Else return gcd recursion. And I will also make some fix here. I will say if 0, else I will fix like this. then it will work fine. Then it should work fine. Let's see. Loop. If it fails, yes. Now we will create another solution. We'll close this solution. We will copy the code. Close solution. Here. New project. Linear Congruence solution. We will create empty solution. I will add source code, new linear congruence source. Now I will copy the code. I will copy from previous code. Here we fixed. I will copy them all here. Okay. I have some more links. I recommend you watch these videos. Here we need include vector. Save them. I will add it here. int gcd int a int b. Here we are calculating GCD int r y r a b not equal to 0. A equals b, b equals r. Here we return b. This is GCD, Euclidean algorithm. Okay, so we added one. Now we are calculating linear congruence. int linear congruence int a int b int k int b. It should be SDD vector int s. Here the very first step is we have to calculate z int z gcd a p. If g is 1, it means one and only one solution, unique solution. Else else if g is not 1, I will do like this. Else if in this case g is 1, in this case g cannot be 1, so else if k modulo b is 0, it will have multiple solutions. Multiple and g number of solutions, g number of solutions. Here return solve. We create vector solve here, std vector int solve. Here now we solve for for inverse. It solves the equations like this: ax modulo k mod b. We declare int x y gcd. We are getting inverse x loop. We can use loop or recursion, the same. We are calling Euclidean algorithm. Multiplicative inverse of a. Here a, b, k, no, a, b, then x, y. Like this. Then at this point, the result would be, we have to make the result to positive. I make here. I will put it here. int modulo positive int a int n. We make a mod n positive. So a equals, we first take modulo m, then return a less than 0, then a plus m, else m. We are making another one. I would say void modulo make positive. This is not m, n. N. Then if a less than 0, then a plus n. We are making modulo positive. Okay. Then here we have to make x positive, modulo make positive x and b, this value. Then solve in place back, the result would be x times k modulo b. Here we are also calling GCD loop int y. No, we have to define int a1 a over z p1 a over z and b over z k1 k over g, like this. Then GCD loop a1 b1 x y, like this. We have to create int x y. Then we make modulo, make positive x p1. Now the first x is the first solution. I would say y, because we can use this one. X times k1 times p modulo p1. This is the result. So solve in place back here y. We are using the variable y because it is not used in this algorithm. Here I would say x is inverse multiplicative inverse a1 of a1 mod b1. Y is first solution. For int I equals 1 less than g plus I, the next solution would be b1. Then we save the result, solve in place back y. So we solved all solutions. Now we can return here. I will put here x is multiplicative inverse of a mod b. Make x positive modulo. Save it, put it to container, solve. Here x will be x is multiplicative inverse of a1 mod b1. Put y to container, solve. Next solution, put it to container. Now we completed our algorithm. Now we are solving. We first solve equations like this. SDD, Cout. Oh, I need to create a vector function, vector string. Okay, here. SDD, O string operator. SDD, O string, OS constant vector int b. I need std here. If b empty, return os AOTL last element b c end this will be last element std no cout os for auto itr b c begin itr not equal last element plus itr cd cout itr os last element return os. Okay, now we are solving the equation. First we will solve 17x modulo 3 3 congruent to 3 mode 29 std cout solution. It will give us linear congruence. The first will be 17 3 29. We will first execute. We have to put it back side. Now let's run. I have to put it back. Let's run. Okay, the answer 7 is correct. Now I will try another one here. The next one will be, I will copy them here. 2x 6 mode 8 2 6 mode 8. It gives error. It doesn't currently work. Let's fix this. It doesn't work. Linear congruence. Okay, else if g equal 1, else k modulo b, not b, it should be g, k modulo g, k modulo g 0, then it should work. Okay, two solution. 7, 3, 7 is the solution. Now we try another one. Here we try another one. 6, 6, 9, 27, 6, 9, 27. The answer is 6, 6, 15, 24. See, these samples, I got these samples from this YouTube, from Cathy's here. I got these samples from sample test code from this.
Part 2. Let's take a look at, and those are the two solutions.
From this YouTube.
So you start.
For example, 2, 6, 8. The result is 3, 7. 2, 6. The result is 3, 7. 3, 7. And I will show you once again. 2, 6, mod A, 3, 7, the solution. And also, in this case, the result, 6x congruent to 9, mod 27, the result is 6, 15, 24. So, this case, 6, 15, 24. If you compare it, you can find the solution is correct. So this way, we implemented linear congruence. In this case, we used, loop. In this case, loop. We can also use recursion. I will try to recursion. Recursion. I will also change it to recursion. Now using recursion method, we can also try it. Let's see the result. The results are exactly the same. I will upload this source code. I will upload this source code to my YouTube. So please download this source code and try it by yourself. Thank you for watching.